Class, we have done number 8. Dah ya? Dah ke belum number 8?
Belum.
We have done number 8 or not?
Belum.
Oh, belum. So we stop at number 7. Yeah. Class, we stop at number... At what number? Tak tahu.
Itu
Number
7.
7, we stop at number 7.
Yep.
Yep, betul.
80.
Okay, so we continue number 8. An AC voltmeter is to be used to measure the RMS voltage across the 15K resistor. If the voltmeter uses half-wave rectification and a 100 microdiameter voltmeter movement, if it is set on its 10 volt range, and if Rm is equal to 1.5 kilo ohm, what reading will be obtained? Okay. Reading. Okay, so reading of VR2 here. Okay, so halfway rectification, we want to measure the VR2 read by the voltmeter. This is series circuit. We have AC supply of 20 VRMS. We have R1 and R2 connected in series. Okay, and we have voltmeter to measure the voltage across R2. So the voltmeter should be placed in parallel with R2. The IFSD of the voltmeter is 100 microamps. Rm is equal to 1.5 kilo ohm, and the range for this voltmeter is to 10 volt. Okay, 10 volts. Okay, so how to find the voltage of R2? Okay, read by the voltmeter. So we have to find the R total of the meter. Okay, so this is the actual voltage of R2 from calculation or from the theory. This is voltage divider principle. To find VR2, we take 15K divided with 15K plus the resistors that connected in series with it. It is 25 kilo ohm and multiply with the voltage source 20. Okay, so the VR2 from the calculation is 75 kilo ohm. 7.5 volts, not kilo ohm. Okay. Seven point five. Okay, 7.5 volts. Okay, and then we want to find the R total of the meter. So R total is equal to R total of the meter is equal to V over I. V here is VDC. VDC is equal to 0.45 multiply with VRMS divided with current. So because of half-wave rectification. So 0.45 multiply with the voltage range of the voltmeter, it is 10 divided with 100 microamps This is the current of the meter. Okay. So the R total of the voltmeter is 45 kilo ohm. Okay. 1.5 kilo ohm is only the resistance for meter movement PMMC. Okay. This not include RS of the voltmeter. So the total voltmeter, which is RS plus RM, is equal to 45 kilo ohm. And then 45 kilo ohm is here it is parallel with 15K, so we have to find the equivalent R of this connection. So 15K parallel with 45K is equal to 11.25 kilo ohm. Hence, we are to measure by the voltmeter is the new R equivalent. It is 11.25K divided with 11.25K plus 25K multiplied with the voltage source of the circuit. We get 6.2. So 6.2 is the voltage measured by the voltmeter. 7.5 is the actual voltage. It is from the calculation. Any question? Any question? No?
No.
Okay, we continue to number 9. Two different voltmeters are used to measure the voltage across the 22 kilo ohm resistor in the circuit. Meter A has AC sensitivity of 10 kilo ohm per volt, a guaranteed accuracy of 98% at full scale, and is set on its 200 V range. Meter B has an AC sensitivity of 4 kilo ohm per volt, a guaranteed accuracy of 98.5% at full scale, and is set on its 100 volt range. Which meter will provide a more accurate result? Is the answer? The answer is meter A will provide accurate result. Okay. Loading error. Okay, this actually the question did not ask on. So this is okay. This is error contributed by the voltmeter. Okay, loading error meaning that error produced due to voltmeter loading effect. Okay, from the answer we found that the error, the loading error of meter A is lower than meter B. Meter A is more accurate. Okay, this is the solution. Okay, this is meter A. Meter A as 10 kilo ohm per volt, 98%. At full scale meaning that 2%. The accuracy or the error of the meter is 2%. Okay, in chapter 1 we always use to, okay, let's say 98%, this is accuracy, so the error of the meter is 2%, but sometimes we call it as accuracy. Okay, so voltage range of meter A is 200 volts. Okay, so now we want to find, because the question is asked to find accurate which meter provide more accurate result. Accuracy rely with error. Okay, so we want to find the error of this measurement. Okay, so now we calculate V at 22 kilo ohm. Okay, the measured voltage. So okay, so this is the actual voltage drop across 22 kilo ohm. 22K divided with 22K plus 39K multiplied with the voltage source 150. So for 54. Okay, so 54 volt is the voltage across R2. This is the actual voltage. This is from the formula, from the calculation. So now we want to find the voltage measured by meter A. The first step is to find the R total of meter A. Okay, so R is equal to S multiplied with V range. S is given, it is 10K multiply with voltage range of this meter, it is 200, and we get 2 mega ohm. Okay, 2 mega ohm. So actually we have to find R total. Okay, R equivalent of this connection. Okay, so what is the R equivalent? Sarih saya selalu panggil orang lah. Sarah. Sarah? Sarah. Tak payahlah. Nur Alifah Iliana. Okay. Nur Alifah Iliana. Ada tak? Ada tak Nur Alifah Iliana? Nur Alifah Iliana ada tak? Ke tak ada mic? Okay. Alifah Iliana tak ada mic Tak apalah. Ambil orang lain lah. Izzati Nurina ada mic tak? Ada mic tak? Sejuk tu kat sini. The temperature here is 18. Okay. Apa yang nak buat ni? Equation. Tak ada mic juga. Okay. How to find R equivalent? R equivalent is equal to
21.76 kilo ohm.
Okay, how to calculate?
2 mega darab 22K bahagi 2 mega tambah 22K.
Okay, 2 meg divided with 2 meg plus berapa? 39 39 Okay, 39K and then multiply with apa? Okay, and then did you get 21.76 kilo ohm? Class? Dapat tak? Dapat tak? Dapat tak kelas? Kelas? Did you get this answer?
Dapat.
Hah? Dapat tak? Got the answer? Mana ada ni? Aduhai. 2 meg parallel with
22K.
Okay. 22K. Okay. And then plus 22K. Apalah ni? Ni apa ni? I buat ni. Voltage divider principle. Tiba Okay, and then get the answer. Got the answer? Dapat kan? Okay. When we put a very large resistor parallel to small resistor, we will get the about the smaller resistor. Okay, because 2 meg is too large. Okay. The resultant resistance is approximate to the smaller resistor. Okay, and then so now we want to find VR2. Okay. By using the new R equivalent. So 21.76K divided with 21.76K plus 39K multiplied with the voltage source 5150 the RMS. So the voltage measured by the meter A is 53.7272 volts. Okay, and the error of this measurement because of meter A is, okay, the actual minus the measurement divided with the actual multiplied with 100, we get 0.7%. Okay, this is using meter B. So this is the first step here. The same process is repeated. We find our total of meter B first. R is equal to S multiplied with V range. Okay, S is equal to 4K multiplied with 100 volts. We get 400 kilo ohm. R equivalent here is equal to 400 kilo ohm parallel with 22K. We get 20.85 kilo ohm. The next is to find the voltage measured by this meter B by using voltage divider principle. We get 52.25, and then the error of this measurement is the actual VR2 minus the measurement divided with the actual multiplied with 100, we get 3.22%. So from this error, it is obviously shows that meter A is more accurate. Okay. Okay, class, any question? Any question regarding tutorial 3?